The universe is vast, silent, and beautiful, but our understanding of it is often filled with noise, ideas that sound right, but are completely wrong. These cosmic myths are everywhere, passed down until they feel like facts. But what's the real story? 4 space myths you definitely believe. Let's fix them. We're going to cut through the confusion with clear, simple science. No fluff, just the facts. Big sky. Bigger misconceptions. Let's begin. Myth 1. The idea of a permanent dark side of the moon is one of the most persistent myths in astronomy. It conjures images of a mysterious, perpetually shadowed realm. But the truth is, the moon does not have a permanent dark side. The misconception comes from a phenomenon called tidal locking. Over billions of years, Earth's gravity has slowed the moon's rotation until it perfectly matches its orbit. It takes the moon about 27 days to spin once on its axis, and the same amount of time to orbit the Earth. The result? One face always points toward us, but this doesn't mean the other side is dark. As the moon orbits Earth, every part of its surface gets sunlight. A lunar day, from one sunrise to the next, lasts about 29.5 Earth days. So day and night sweep across both the near side and the far side. The correct term is the far side, simply because it's the hemisphere we can't see from Earth. And thanks to missions like NASA's Lunar Reconnaissance Orbiter and the Apollo astronauts who flew around it, we know the far side is often brilliantly sunlit. So, there's no mysterious dark hemisphere, just fascinating orbital mechanics. The truth is simple: the far side is not the dark side. Myth 2. Ask anyone to draw the sun, and they'll probably reach for a yellow or orange crayon. We see it that way every day. But in reality, the sun isn't yellow at all. If you were an astronaut looking at the sun from the International Space Station, you'd see its true color, a brilliant, pure white. That's because the sun is what physicists call a black body radiator. It emits light across the entire visible spectrum, all the colors of the rainbow. When our eyes see all those colors mixed together at full intensity, our brain perceives it as white light. So why does it look yellow from the ground? The culprit is Earth's atmosphere. As sunlight travels through the air, tiny nitrogen and oxygen molecules scatter the shorter, bluer wavelengths of light more effectively. This is called Rayleigh scattering, and it's the same reason our sky is blue. With some of the blue light scattered away, the remaining light that reaches our eyes is skewed toward the red end of the spectrum, making the sun appear yellow. At sunrise or sunset, the light passes through even more atmosphere, scattering even more blue light and making the sun look orange or red. In space, there's no atmospheric filter, no haze, just the sun's true, dazzling white. The simple takeaway: the sun isn't yellow. We are just looking at it through a blue filtering atmosphere. Myth 3. We've all seen footage of astronauts effortlessly floating inside the International Space Station. It's easy to assume they're weightless because they've escaped Earth's gravity, but that couldn't be further from the truth. Gravity is everywhere. It holds galaxies together and keeps planets in orbit. At the altitude of the ISS, about 400 kilometers up, Earth's gravitational pull is still about 90% as strong as it is on the surface. So, if gravity is still so strong, why do they float? The answer is that astronauts, and the station itself, are in a constant state of free fall. They are literally falling towards Earth, but they're also moving sideways at an incredible speed, about 28,000 kilometers per hour. This immense sideways velocity means that as they fall, the Earth's surface curves away beneath them at the exact same rate. They are perpetually following the Earth, constantly missing it. This is what an orbit is. Inside the station, everything is falling together. The astronauts, their tools, the walls. Since everything is falling at the same rate, they feel weightless relative to their surroundings. This condition is properly called microgravity, not zero gravity. It's the same planet and nearly the same pull, just experienced from a new, perpetually falling frame of reference. Myth 4. Black holes are the ultimate cosmic monsters in popular culture. Voracious vacuum cleaners that roam the universe, sucking up everything in their path. This makes for great science fiction, but it's a fundamental misunderstanding of how they work. Black holes don't suck. They are simply objects with an immense amount of mass packed into an incredibly small space, creating an extremely strong gravitational field. But from a safe distance, their gravity behaves just like any other object of the same mass. For example, if our sun were to magically be replaced by a black hole of the exact same mass, Earth and the other planets wouldn't get sucked in. They would continue to orbit it just as they do now. We'd freeze, of course, but our orbit would be stable. The danger zone is the event horizon, the point of no return. If you cross this boundary, the gravitational pull becomes so strong that nothing, not even light, can escape. But you have to get very close for that to happen. Even the terrifying effect known as spaghettification, where extreme tidal forces stretch an object apart, is a local phenomenon that only occurs very near the black hole. It's not a galaxy-wide threat. A black hole is a big mystery, but it still follows the simple rules of gravity. Distance matters. So, to recap, the moon has a far side, not a dark side. The sun is white, not yellow. Astronauts are in free fall, not zero gravity. And black holes are just massive objects, not cosmic vacuum cleaners. The universe is more elegant and interesting than the myths we tell about it. Keep looking up, bust a myth. Then ask a better question.